These are the 6.2 Part 1 notes, and we're going to start covering the unit circle. Now, the unit circle, what is the unit circle? The unit circle allows us to consider right triangle trigonometry for any triangle, and we can relate it to the cosine and sine values to the xy values which are found on the circumference of the circle. So the radius will always be treated as the hypotenuse of the triangle. This should not be circle, this should be triangle. With respect to the x-axis, i.e. the right angle will always lie on the x-axis across from the angle at the origin. Now the key here is that the hypotenuse of our right triangle, or the radius of our circle, the radius of the unit circle, is equal to 1. And then the hypotenuse of every triangle will be equal to the radius. So the hypotenuse of every triangle in the unit circle is also 1. And what this does is it allows us at every point we'll have an x, y point. Since we're making our hypotenuse 1, what we can say is that the adjacent side will be equal to the x value, and the opposite side will be equal to the y value, because every angle that we're looking at here is going to be based here. We're going to base our angle based off of what is coming out of the origin. And then when I say that our right angle always lies across from the origin, this is what I mean, is right here we can see that our right angle is always going to be on the x-axis across from the origin. Now there are going to be times when we have other angles, like we're going to have angles that are over here, and we're going to consider that triangle existing here, and this is its right angle. Just like we'll have right angles here, and they'll exist here, right angles or right triangles here and here. And then so basically what we're going to be able to do is we're going to be able to look at a right triangle in every single quadrant, and we're going to do so based off of having those right angles that lie opposite the origin or the middle of our unit circle. Now there are three really common triangles when we think of right triangles. Well, there's two. Technically there's two, but it becomes three. So the two triangles that we think about are a 30, 60, 90 degree triangle and a 45, 45, 90. Those are the two common triangles, and then they create three triangles, because when we think about it, all of our angles that we're concerned with are going to rise from the origin. So we're always concerned here. Our theta is always going to arrive here. We're not thinking about the angle that occurs up here. So because of that, we need to do the 30, 60, 90 triangle twice. Once here, where our theta is 30 degrees, and then once here, where our theta is going to be 60 degrees. So we'll have that 30 degree angle and the 60 degree angle, and then in that case, this is 30 degrees up here, and this is 60 degrees here. So we have that 30, 60, 90 triangle two times within the unit circle, and then the 45, 45, 90, since 45 degrees is the same, that doesn't repeat itself. It only occurs within the quadrant once. So we have these very common angles, and then we also have the radian measures for all of these. A 30 degree triangle is pi over 6, a 45 degree is pi over 4, and a 60 degree angle is pi over 3. We've already learned how to convert radians to degrees. These are radian to degree conversions. These are things that will have to be memorized, and you're going to see that at the end, that you're going to have to memorize quite a bit of this circle. And you're going to have to know everything about this circle by memory really soon. So that's how we break down the triangles. Now, obviously, I've only done this in quadrant 1, but what we're going to see is we're going to see all three of these triangles occur here in quadrant 2, they're going to occur in quadrant 3, and they're going to occur in quadrant 4 as well. So we're going to end up having three triangles in each separate quadrant, along with some special angles that exist on the unit circle. So now, once we know that the angles within the first quadrant, we can use the fact that we are moving with respect to the x-axis across the circle to identify all of our angles. So as you can see here, we've got a 45 degree angle that exists across. This is a little bit different. This isn't quite the unit circle because we've got a radius of a square root of 2. But when I do a 45-degree angle, they all end up with the exact same measurements if I'm working within a circle. So here, the radius of this circle is the square root of 2 as opposed to 1. But we can see that the y values and the x values are the exact same across the circle. Now I might change direction. Like here, my x is -1, while my x is +1 over here. Here, my y's are -1, while up here, my y's are +1, but the magnitude of this is the same. My x and y's don't change their size, given the fact that I have a consistent radius through this circle. And that's going to happen with all of the triangles, because I'm measuring all of these with respect to the x-axis. So again, we look here, I'm thinking about these triangles as they occur from the x-axis. So here's my right angle, I've got the +1 rising up, I've got the -1 that's going down in relation to my x-axis. So now I can start breaking down all angles and degrees of my unit circle. First thing that I have is I start here. I'm always starting on the positive x-axis. This is 0 degrees. This is the first angle I need to know of my unit circle. And this is also the same thing as 0 radians. So I can also write this as 0 radians. From now on, I'm not going to write out the word radians. I'm just going to write out its pi-based value. We've already learned these three angles. This is a 30-degree angle, or pi over 6. This is a 45-degree angle, or pi over 4. This is a 60-degree angle, or pi over 3. And then finally, this is a 90-degree angle up here. And then a 90-degree angle is going to be the same thing as pi over 2. You have this on your chart. You can also do this via conversion factors. Now that I'm here, I start breaking down what my other angles are. Easiest angle to think about is the midway angle, or the middle angle of every quadrant. So when I say the middle angle of every quadrant, I'm talking here, the one that falls in between the other two of each quadrant. All of these are going to be similar to pi over 4 because again, right here is a 90-degree triangle, or a right triangle, that has the unit measures related to pi over 4, just like over here. This is going to be pi over 4 away from this x-axis. But it's not pi over 4 because, again, we're not measuring this angle in relation to its closest x-axis. We're always measuring our angles in relation to this x-axis, our initial side of every single angle. Our initial side of every angle will be over here. So I'm going to go through and I'm going to label the fact that all of these angles that are in the middle are over 4 away from are all pi over 4 related angles. This one, pi over 2, is the same thing as 2 pi over 4, and I'm adding another pi over 4 to that. So this is 3 pi over 4. Here, I've got another over 4. This is going to be 5 pi over 4. And then finally, I'm going to have 7 pi over 4 here. Along with this, I'm going to look at the other parts of my circle, just the main quadrants. This is pi radians over here. Half of a circle is pi radians. And down here is 3 pi over 2 radians. And this is also 2 pi radians. We looked at this in our activity in class. We've got 2 pi radians. 2 pi radians is equal to 360 degrees, which is a full circle. And this helps us make sense of the pi over 4 radians. This angle here is another pi over 4 added to pi, which is 5 pi over 4. Just like this 7 pi over 4 is another pi over 4 added to the 3 pi over 2. So we can think about that in terms of our major angles there. Now filling in degrees, 3 pi over 4 is going to end up being 90 degrees plus 45, so this is 135 degrees. Pi is 180 degrees. We should know a half circle is 180 degrees. 5 pi over 4 is going to be 45 degrees plus that 180 degrees. This is 225 degrees. 3 pi over 2 is going to be equal to 270 degrees. That's 90 degrees plus 180 degrees. And then 7 pi over 4 is going to be another 45 degrees on top of this. So this is 315 degrees. So now I got my pi over 4 angles measured. Next thing that I want to look at is I'm going to look at my angles which are closest to the x-axis. So this angle here is closest to the x-axis, or this line is closest to the x-axis, because when I look, this is where the x-axis is, this is where this angle is, this is the closest one. All of these angles are over 6 angles. Any angle that is close to the x-axis when we're talking about the unit circle is an over 6 angle. They are close to the x-axis. When I think about this, I think about the fact that this is pi over 6 away. So this angle here was pi over 6 away from the x-axis, so I added pi over 6 to 0 degrees. Over here, this is pi over 6 less than pi. So this angle ends up being 5 pi over 6. Just like this angle here is another pi over 6 away from pi, so this is 7 pi over 6. And then when I look at this final angle, this is 1 pi over 6 away from being 2 pi, so this is 11 pi over 6. So that's the radian degrees of all of those angles. They're all pi over 6 angles. That's just a way to think about it. And now finally, when I think about the degrees, this is 30 degrees less than 180, so this is 150 degrees. This is 30 degrees more than 180, so this is 210 degrees. This is 30 degrees less than 360 degrees, so this is 330 degrees. Now finally, that leaves my angles which are closest to the y-axis. Again, if I look at this angle here, this is closer to the y-axis. Here's the y-axis, here's this angle. It ends close to the y-axis. All of these angles are going to be based on pi over 3 values because they're close to the y-axis. So all of these are going to end up over 3. Then I start thinking about it. This is another pi over 3 added to, this is going to be another pi over 3 added to the last pi over 3, so this is 2 pi over 3. Just like down here, this is going to be 180 is 3 pi over 3, so I'm adding another pi over 3 to this. This is 4 pi over 3. And then this one over here is going to be another pi over 3 added to that 4 pi over 3, so this is 5 pi over 3. Now finally, when I think about degrees, pi over 3 is 60 degrees, so we're adding another 60 degrees here, so this is 120 degrees. We're adding 60 degrees to 180 degrees, so this is 240 degrees. And then we're adding another 60 degrees there, so that's 300 degrees at this 5 pi over 3. So now we have every angle of the unit circle in both degrees and radians, and this is something that will have to be memorized. You're going to have to know this off the top of your head. I've given you some things to help you remember it. Knowing that all of the angles which terminate closest to your y-axis are over 3 will help. Knowing that all of your angles which terminate closest to the x-axis are over 6 will help. Knowing that all of your angles that terminate directly in the middle of your unit circle terminate at pi over 4, that will also help you as well. This might not be the easiest thing to think about sometimes, but you're going to have to memorize it, and students have done this every year. This might seem daunting right now, but I promise you, once you dedicate the time to making sure you memorize this and knowing it off the top of your head, this won't be as scary as you think it is. This is pretty straightforward. All right, so now that we know the angles of the unit circle, what we want to know now is the xy values of the unit circle. Because again, once we know these xy values, once I know what my adjacent and my opposite are, it's going to make solving for the trig ratios like 3,000 times easier. My life is going to become much, much, much simpler once I start solving for trig ratios knowing these sides. So, xy values of the unit circle. What I need to think about are my two triangles. So when I think about this, I've got a 45, 45, 90 degree triangle, and it's shown here. What this means is that angle B and C are equal to each other, and since angle B and C are equal to each other, that means my side length C and my side length B are also equal. C is equal to B. So that means I can go through, and when I solve for my hypotenuse, remember, in the unit circle, the hypotenuse is always equal to 1. So when I solve for my hypotenuse, I can write x squared plus x squared is equal to 1. Since both side lengths are the same, I can write them as equal side lengths. This means 2x squared is equal to 1. X squared is equal to 1/2. X is equal to the square root of 1/2. X is equal to the square root of 1 over the square root of 2. X is equal to 1 over the square root of 2. Multiply both sides by the square root of 2 over the square root of 2. And I'm left with the square root of 2 over 2. So that means that both side lengths for a 45, 45, 90 triangle are the square root of 2 over 2. All right, now we want to consider a 30, 60, 90 degree triangle. Now, I can't solve this one as easy because they're not equal sides. A 30 and 60 aren't equal, and then I'm not going to be able to just make up a ratio to figure that out. But what I can do is if I put two 30, 60, 90 degree triangles back to back, I end up with an equilateral triangle of 3 60-degree angles. This is a 60-degree angle, 60-degree angle, 60-degree angle, all of which have sides of 1. So now what I can do is I can say that here, A plus A is equal to 1, 2A equals 1, A is equal to 1/2. So now I know that the side opposite 30 degrees is equal to 1/2. Now that I've gone through and I've created those equilateral triangles to figure out that my side A is 1/2, now I need to solve for B. So 1/2 squared plus B squared is equal to 1. 1/4 plus B squared is equal to 1. B squared is equal to 3/4. B is equal to the square root of 3/4. B is equal to the square root of 3 over the square root of 4. B is equal to the square root of 3 over 2. And now this is my side length opposite 60. So now I have all my side lengths. Side lengths opposite 45 degrees are always root 2 over 2. Side lengths opposite 30 degrees are always 1/2, and side lengths opposite 60 degrees are always the square root of 3 over 2. Now I can go through and I can label x, y values for all of my angles within the unit circle. I can go through and label every single angle in the unit circle and its side length values. Now you'll see that this unit circle has already given us our xy coordinates for the main, for x, y, negative x, and negative y axes here. And again, this makes sense because the radius of our circle is always 1. So if our radius terminates on an axis itself with a radius of 1, it's going to end with whatever axis it's on at 1 or -1 depending on the direction, and 0. So at 0 degrees or 0 radians or 360 degrees or 2 pi radians, your xy values are 1, 0. At 90 degrees or pi over 2 radians, your xy values are 0, 1. At 180 degrees or pi radians, your xy values are -1, 0. And then at 270 degrees or 3 pi over 2 radians, your xy values are 0, -1. Now working from here, I'm going to work with those unit circle angles I just found. I'm going to start with my 45 degree angles, my pi over 4. My adjacent and opposite sides were both 2 over 2. The opposite of a 45 degree angle doesn't change, or the side lengths of 45 degree angles don't change. The side lengths are the exact same because we have got an isosceles right triangle, so it's root 2 over root 2 for our side lengths. Now the nice thing is, you might be saying, how are we going to fill in the rest of the circle? This is overwhelming. Every single pi over 4 angle is going to have these exact same magnitude of side lengths. What I do have to remember is in quadrant 2, my x values are negative and my y values are positive. In quadrant 3, my x and y values are negative. And then in quadrant 4, my x values are positive, but my y values are negative. Every single pi over 4 angle is going to have the same magnitude for side length. So these are all going to be root 2 over root 2 for side length when I have a pi over 4. Now I just have to go through and pay attention to my signs. In quadrant 2, my x value is negative and my y value is positive. In quadrant 3, my x and y values are negative, and in quadrant 4, my x value is positive and my y value is negative. So now I've got every single side length labeled for all of my pi over 4 angles. Looking at my pi over 6 angles. The side length opposite 30 is 1/2. The opposite is equal to your y value, so your y value here is going to be 1/2. Because 1/2 is opposite your 30-degree angle, that means the side length that has to be adjacent to your 30-degree angle is the side that's opposite the 60-degree angle, or root 3 over 2. Now that I have this, this is positive and positive because it's quadrant 1. Both x and y values are positive in quadrant 1. Now I can go and at every pi over 6 value, I can put in the same magnitude for side length, root 3 over 2, and 1/2. Root 3 over 2 is my x, 1/2 is my y. I'm in quadrant 2 here, so just my x value is negative. Root 3 over 2 for x, 1/2 for y, because it's a pi over 6. It's going to be the same magnitude for x and y values, and both of these are negative because I'm in quadrant 3. And then this is going to be root 3 over 2 and 1/2. And only my y value is negative because I'm in quadrant 4. So that's how we go through our pi over 6. Your y value is always 1/2, your x value is always root 3 over 2, and then we just pay attention to which quadrant I'm in to make sure that the negative or positive values are marked as negative or positive. Finally, the last thing that we have is our pi over 3 angles. Pi over 3 angles are going to be the reverse of 30-degree angles, because again, now we're talking about the opposite angle or the other angle in this 30, 60, 90 triangle. So now your opposite side, or your y value, is root 3 over 2, and your adjacent side, or your x value, is 1/2. And it's going to be the same magnitude all the way around this circle, and then we just have to pay attention to what quadrant we're in for the sign in front of which value. So yes, this might seem a little bit daunting right now, but as we go through this, as you practice this more and more, it's going to just become secondhand knowledge. You're going to get really, really used to this, and you're going to have this memorized, and you're going to need to have it memorized. I'm going to have a little speech for you prepared about how if you do not know this for not only AP Calculus, but regular calc, if you have to constantly reference things, draw out the unit circle, do all your work, your life is going to be a lot harder. We're getting to the point in the year where there are some things that are just going to have to be memorized. Understanding how all these things relate definitely helps with memorizing it. And I would even admit that like a really good skill is to draw the unit circle at the beginning of a test, like from knowledge, or have like a little sketch. Every single test I ever took from Algebra 2 to BC Calculus, one of the first things I did, if I knew that trigonometry was going to be on the test, I drew a unit circle with quadrant 1 up in the little corner of the front of my test, just so I had a reference point to come back to. It didn't have to be extensive. I just needed something to reference because I knew when I got to certain angles, I was going to have to come back to that and just give myself some mental refreshers. And it's a good skill that I think that you guys might want to pick up on as well. So now we've filled in the entire unit circle. Soon you're going to be given a blank unit circle, and you're going to be expected to fill in every angle in degrees and radians as well as XY coordinates. I would expect this to happen the second class back from spring break. So I'd expect the second class after spring break, you're going to come back and you're going to have to do all of this by memory. This is not an unfair task. You can remember the basic principles and angles given. You can even use conversion factors to find your angles and radians. And then memorizing the X and Y coordinates are easy once you understand all of the angles. So if this is something that is confusing you, please come talk to me. I can explain this in a million different ways to kind of help people out. You can talk to Miss Flynn, you can talk to Mr. Loudit. They love the unit circle as well. This is something that, like, when you break it down, it starts getting really logical really quickly, and there's some pretty fast patterns you can pick up on memorize. I've handed you what I think is the easiest of thinking about where the angle terminates in relation to the X and Y axis and where you see the angle in the quadrant. because once you know what the angles are, once you know how those relate, it's really easy to form your x and y coordinates. The x and y coordinates make a lot of sense. And I'll explain this more in class. I'll talk about this more in class so we're all aware of what we're looking at. If you guys have any questions or concerns, please reach out. There's no homework tonight. Just make sure that you're studying this. I would actually go through and probably draw this 2 or 3 times. Obviously, I can't make you do this, but this is something that I would start doing now. You want to have this memorized, and the sooner you have this memorized, the easier your life is going to be. Any questions or concerns, reach out, and have a great night.